Hello, ISB families. Welcome to today's parent conference, all about how we teach math at ISB. My name's Tina Gehagen, and I will be sharing with you all about math in the primary years program. I am currently the third grade homeroom teacher, and I'm excited to share some information with you today. I wanted to start with a quote from Jo Boaler, who is a professor at Stanford University. And she shares in her book, Mindset Mathematics, that mathematics is not a set of methods. It is a set of connected ideas that need to be understood. When students understand the big ideas in mathematics, the methods and rules will fall into place. This really fits well with our inquiry approach at ISB and how most of the time, whenever available, we will bring math into our inquiry units, or if there are other additional math lessons that need to be taught, we will still approach them with an inquiry mindset. And so as the students look and try to understand and develop their thinking around math, a lot of the methods and rules will present themselves and they'll have connections with what the students are learning. Today, I want to ask for you to get a few materials. So you can pause me at any time during the presentation for any of the things that you would need, or when you are working on some of your own math challenges. So today, if you could get some paper, a pen or pencil, and bring with you an open mind. I wanted to start with a couple inquiry questions, just like I often do with the students in my classroom. So first, I want to learn about your experiences when you were learning math and what you would like to explore today. And if you have any challenges at home when working with your children in math. Even though you won't be able to share this with me today, if you write it down, you can always email it to us or your child's teachers, or it will just help you to focus your inquiry as you're listening today to help you find some of the answers to these questions. Again, you can pause me at any time if you want to write down some of your own ideas. I did ask these three questions to some of the parents I know, along with the grade 3 homeroom, and I received a few answers back. And so I've selected some to share with you today. Some of the parent responses I received were, those who are successful in mathematics are like successful magicians. I really struggled with math in regards to computation, keeping everything in order and following the steps in multi-step problems. I think it could be valuable to learn how to support students in learning mathematics with less vocabulary and more visual, hands-on support. I would like to better understand how math is taught at ISB. Framing the right moment as a chance for my child to explore whatever math questions interest her. And my child did ask me recently if multi-universes exist. I love how I can see some of the answers from the parents where they were connecting with questions their students have brought home from school. Often, when students ask us questions, we do not just give them an answer, but we ask them where they could look. How could they find the answer on their own? This will develop an even further inquiry and curiosity to search for the answers. We'll do this in math as well, so that they have more chances to practice and to investigate and start making connections with their own questions to the world around them and find connections of how math can be found all around us in everything we do. I wanted to go over some acronyms for today. You will probably hear us share some of these acronyms, such as DP, that is for the diploma program, CCSS, Common Core State Standards, IRW, in the real world, MYP, the middle years program, PYP, the primary years program, and ICT, Information and Communications Technology. So you'll see how ICT fits in with math as well. Today we will see how we establish rigor in our mathematics program and see how math is taught in a way that is connected, relevant, and interesting to students. Math in the PYP. We have a scope and sequence in math to outline the learning outcomes at each grade level. So when possible, we will match the scope and sequence tasks with our units of inquiry and see what parts of math can be investigated through the same lens of our units of inquiry. And then when needed, we can also continue to teach inquiry math units to make sure that we are meeting all of the scope and sequence, the Common Core state standards for every grade level. As our students come from all over the world, we know that our learning outcomes may be different from previous schools and experiences, and we work to ensure that we are able to meet the needs of all of our students. As this is very common, we will use many different approaches to math that have activities that have low floor, high ceiling, as we like to call it, so that everybody can approach the same math challenges, questions, and work towards learning and experiencing and developing their math understanding to reach the Common Core state standards and the scope and sequence that we've outlined for each grade level. So today, we will talk about what we will do, how we do it. We'll share some examples and offer some takeaways. So you'll hear from each of us kind of following through this in the PYP, MYP, and DP. So let's start with the PYP. The PYP philosophy adds depth to student learning. So math in the PYP also provides opportunities for students to work through all of these, and I will try to share an example as I briefly talk to each one. So students will have opportunities to count, sort, match, compare objects, shapes, and numbers. A lot of times this is with hands-on manipulatives as students are entering the PYP, and it moves all the way through to our grade 5 students who, as they're in exhibition right now, are still doing those same things with the research and the information they're finding connected to their exhibition. I like to talk about the calendars that we use, and I will share a picture in a little while, that each classroom has a math calendar, and it brings in so many of these different activities as they're filling out the calendar for the month. And the next one, recognizing and continuing patterns and relationships, is such an important skill in math. And as they're doing their calendar, they're provided with opportunities. Even though we are recognizing patterns in everyday math, our calendars really pull this in. They select and use appropriate mathematics operations, computations, and units to solve numerical and word problems. So students are doing this at any level. I've visited the early years and even see them finding different things mathematically and looking at the world through the mathematical lens. They make reasonable estimates. This year we had the opportunity to read a few books, and as soon as we read estimations in the books we've read in our class, they start looking everywhere and challenging each other. How many chair legs do you think are in our classroom? And if we look down at the river, how many rocks do you think are in the river? And we can talk about some of the different skills we learned in math to try to find a more reasonable estimate as we think about those things. Students are becoming confident and competent users of ICT and mathematics learning. I'm going to go again to our current unit of inquiry on sharing the planet. And students are doing just that. We are collecting data by the river, looking at pollution and the environmental impact humans have, how that might affect the height of the water or pollution that's by the river. They're keeping track and tallying this information, and then they're going to make digital graphs using their iPads after we've finished collecting our data. They analyze and make predictions and infer from that data. So using our mathematical understanding, they can continue to develop their thinking around our Sharing the Planet unit. They use mathematical vocabulary, symbols, including informal mathematics. And they develop and implement trial strategies for investigating a range of mathematical questions or problems. I really think that's one of my favorite parts with inquiry maths is the questions that the students come up with. As one of the parents shared that their child asked about um, multi-universes, these are the things that they're thinking about when we're reading. We were reading The Lion of Mars and talking about the universe and planets and stars and just continuing to think what else could be beyond. And so you can see how they can connect math to a lot of our units of inquiry and just think about all of them together. Looking again at the philosophy of math and the PYP. So we often think about what math used to be. Math was the teacher at the front of the room saying, today we're learning about area and perimeter. This is what area and perimeter are. This is how you find area and perimeter. Now you go and try, often handing us a worksheet or opening to a page in our math book and finding the area and perimeter on those examples and seeing if we understood what the teacher had just told us. Now, what math looks more like in our classroom is we still have some instruction time where students are constructing meaning. Then they're transferring that meaning and their understanding and their thinking about the construction of meaning and applying it with their understanding. So it's more of a cycle now where it continues. Students go around the cycle, in and out, think about two together, three together. And so it's a continuation of this cycle as they're developing an understanding of some of the greater concepts. So we're going to try this today. We're going to look at examples of what the students were doing. So here are some examples in the grade 3 classroom. Here's the calendar that I was talking about, and you can see all of the patterns. What do you notice? There's a color pattern. They've worked on multiplication equations for the height times the width. They found the area. They found the perimeter. We made multiplication problems, division equations. So there are so many ways that they can look at patterns just from our monthly calendar. We can write story problems from there. And then to kind of work on developing their understanding, you can see some students are working on measurements in the hallway. So this was connected to our unit of inquiry. We were working with different weights of marbles that they were testing down their marble ramps that they have created, and then measuring how far they would roll. And we were also finding the average by rolling each different weighted marble 3 times. And then the last picture, the third picture here shows when we were working on place value. So a lot of times we work hands-on with different materials so that the students can manipulate it and see how it goes and how things can move. So if we have 10 little cubes, it'll make the stick. And then when you have 10 sticks, it makes 100 square. And then we even have the 1,000 cube. And then a lot of times they'll write out their work on the marker board so we can erase, quickly change things. So now I would love to invite you to try. So you saw how students were inquiring into different math ideas that we just covered. And then I presented the third graders with this exact task. I would really challenge you to try it too for a moment. So it will incorporate your knowledge of both area and perimeter, which we worked on during our March calendar. And the task is for you to build as many different animal enclosures as possible using 36 pieces of fence. Once you've able to make an enclosure with 36 pieces, can you calculate the area for each animal's enclosure? So see if you can draw a couple different ideas, and then we'll compare them with some of the examples from grade 3. Here are some of the animal enclosures in our classroom. So we did use some graph paper that had squares, and you can see here with an area of 81 that the student used 9 for each side. And then they had another enclosure with an area of 72. I love the picture in the middle where one of my students, she was trying to calculate to find the perimeter if you look at her board, and she was trying to figure out what the length of each side had to be in order for the perimeter to equal 36. And she just had this aha moment of, I did it. And she was so excited. And those are the best moments in the classroom, when the students can figure it out and they have an understanding and something makes sense. And we get to see these amazing aha moments. And the third picture here, I took this picture of this student, and then I went back to her the next day and showed her the photo. And I asked her to explain what she was doing. So she told me that she was working on finding the area at the same time as finding the perimeter. But she shared with me that she did a side of 10, 5, 10, and 5, and that only equaled 30. So she knew it wasn't right yet because she needed 36. So you can see the steps of the students working and how many different things that they're developing and understanding and thinking around as they're trying to work out some of these math problems. In the background, there's another student whose enclosure looks like the letter I. I found that one to be unique as well. Here were a few more examples of students who made really unique shapes. And the one that has the outside and then the inside, they said that there was some water on the inside and the animal couldn't live there, so they needed to make 2 enclosures. So as students start to develop an understanding, they can become very creative in their thinking around solving some of these problems or challenges. So some of the key messages from the PYP and math is that process is as important as the product. And this is so important to remember. I'm always telling the students the answer isn't the only thing we're looking at. I really want to see their thinking, not only for if they make a mistake and I only have to correct their thinking or have them refocus their thinking from where the mistake started. A lot of times they'll understand parts of how to get to the answer, but also working through that problem. Sometimes we make little mistakes, but we still figured it out and used the right method to solve the problem, and we can correct those small areas later. So again, the process getting us from point A to point B is as important as the answer. We often talk about this when we're looking at their assessments too. Just reading carefully and making sure that they are thinking through and including the label on their work. And it's all important that when we're presenting our information to our classmates and sharing our thinking and our ideas, to show how we got the answer. And so a lot of time in math is spent where students are coming up and presenting their thinking and telling us how they got there. Because just the answer isn't very helpful. But if they can explain in their own thinking and teach somebody else how to find the answer, they're truly showing their understanding of math. And that brings us to the second point here, that understanding at a conceptual level, not just at a recall level. I was thinking about this as I was preparing to present today, and I thought about how it's like a recipe and how many people can follow a recipe and create a wonderful food dish or dessert. But the chefs and people who really understand food can begin to change an item in their recipe. They can substitute one product for another and still end up with an amazing dish or dessert at the end. And that's how I like to think about math at our school, as we really like to dive deep into the mathematical understanding of different concepts. have students pull it apart, deconstruct it, reconstruct it, and understand how it works instead of just providing the answer. I use this bullseye that you see here in the classroom, where it says the comfort zone, the stretch zone, and the red zone. So, comfort zone means that they feel really comfortable, they already know it, and maybe just need a little bit more learning. The stretch zone tells me this is kind of challenging. I know I've done this before, but I'm not really sure if I can always get it right. And then the red zone tells me that this is stressful for them. It's very hard and very tricky. And so then I know that I can work with those students more to help to build their confidence and bring them into the blue zone as well. And students who are in the blue zone, I know they're ready to be challenged. And so when I prepare math tasks for them, it needs to be an item that will continue to challenge their understanding. So it can take a little longer to become proficient, but our goal is for these mathematicians to be thinkers, problem solvers, articulate in describing the why, not just the how, that they are persistent, that they are risk takers, they are curious and eager to explore and learn, and they are able to make strong connections. All right, that is everything I'm going to share with you from the PYP. I hope that you joined me in the challenge today and that you've learned a little bit more about how we teach math in the PYP. I'm going to hand you over now to Sophia and Miss Love. Thank you.
Hello, my name is Pamela Love, and I'm the head of the mathematics department here at ISB, and I'm excited to share with you a little bit about how we teach math in the MYP program. So we start by aligning the skills that we want to teach, transitioning students from the PYP program all the way up into the DP program. So for this, we use the Common Core standards as a guide. We've chosen the Common Core standards for several reasons. The first, it ensures that we have rigor throughout the whole system. Secondly, it allows us to monitor our results using map testing. So the students take map tests twice a year. And it allows us to progressively check the students' growth as well as to check our cohorts as compared to the international outcomes. And then thirdly, it's designed to connect that PYP to the DP. And so that's the biggest thing that we're looking for. Once we have the skills laid out that we know the students need to learn, then the ideas come down to lesson planning. So I'm going to walk you through the planning of a unit. I'll first show you the main ideas, and then I'll give you an example, and then I'll bring the main ideas back to life again so you can see how they unfold together. So in general, we're going to start with some skill or some concept that we want to teach. And then onto that skill, then we layer all of the MYP philosophy. So firstly, we ask ourselves, how can students inquire deeply into this content? What are some of the key underlining concepts that they'll be taking in this content and extending throughout their math program? Can the students investigate into this content or discover the concepts for themselves? How can students relate to this in a global context? What's the big takeaway that they're bringing into their lives? What approaches to learning would help students support them in mastering this content? So research skills, communication skills, investigating data type skills, but what approaches to learning will help them support in mastering this content? Can students make connections to other disciplines, so either subject areas or outside in the real world? And then how can they take what they've learned and apply it into a real world setting? Are there opportunities for service as action as a result of their learning? And low floor, high ceiling, how can this topic be extended beyond the curriculum for an interested student? Okay, so that's kind of the framework, and from here I'll run you through a grade 10 example of a unit that we've just finished teaching. So here's the typical example in grade 10. The math skill that we were trying to get across was we want students to be able to graph a variety of parent functions, including transformations. So we'd be looking at these parent functions, which you might recognize from your own high school career. And then these transformations, how do we translate it up and down, left and right? How do we refract it? How do we dilate it? So once we've gotten the skill, we're going to create a unit around this skill. One question we ask, how can students inquire into this content? So on the first day of school, we had them open up a graphing software and we had them choose a picture and then try to model an equation on top of it. We started with quadratic, so you can see the student picked a head and he was trying to graph a parabola on top of this. This student did the same with an ear of a cat. There's a little parabola in here, it's quite light, but it's there. And then we've got this rainbow where the student discovered, actually this rainbow is not a parabola. Okay, then can students investigate the content and discover these concepts for themselves? So here we laid out all of the different functions that we want them to study and all of the different transformations that we want them to study, and we put them into this graphing software and we let the students explore what each of these transformations did, and then they came up with the rules that we wanted them to study. Moving on then, how can we get students to inquire even more deeply into this content? So at this point, again in this graphing software, we invited students to either bring in a photo that they liked or to create a photo. And what they wanted to do is they wanted to see if they could create this photo as accurately as possible. So they wanted this curvature of the body. They wanted this curvature of the eyeball, this curvature of this eyeball. So they start asking themselves questions like, which function out of all of the functions that we've studied would best fit this picture that's chosen? How can we make it fit best or just right? Can I translate it? Can I dilate it? How can it be exactly the shape that I see? And so here I'm going to show you, I'm going to kind of walk you through a student's piece of work. Here's the graphing software, and then they dragged the photo in. I added on a little border. And then here, I'm just kind of scrolling through all of the different functions that they've used to create the outside of the face. So you can see they have over 40 functions in here just for the face. And there are many different types of functions as well. So we plop that on, you can see just how well that fits. Got some arms, nose, a mouth, some of the other features coming in. And by the time we're finished, voila, we have SpongeBob. Yeah, okay. It's a very, very, very nice task. Students enjoyed this a lot. Moving forward, we're starting to see the effects of the low floor, high ceiling. So how can the topic be extended beyond the curriculum? So even in the work that you just saw, there were several different functions in there that we never studied as a class. But because they wanted the curvature just right, they researched and they found other functions that they could use. And here's some other examples, because this was the norm. Most people were learning things outside of what we were teaching in the curriculum. So here we have this one. They made a little fish, and you can see in here that we've got some ellipses, and we've also got some domain restrictions. So they're having the function start at a certain point and end at a certain point. Here we have a group that worked with circles, and then also inequalities. So blocking in like this black shape here require that they were smaller than the bigger circle and bigger than the smaller circle. So they were dealing with inequalities in a rather complex way. And this student decided that this shape looked quite a lot like a parabola, but it was rotated. So they learned how to rotate shapes so that he could get the exact shape that he was looking for. Another aspect was, are there opportunities for genuine service as action as a result of their learning? And I think this unit is very special because it actually allowed us to do this in a very, very genuine way. So the pictures that the students created, we ended up using them as the pictures on the front of a Christmas card. And they each designed a Christmas card in groups of 2, or some students worked individually. And then we produced those cards and we gave them out to all of the different grade levels who had raised money for Isaac House. And then the younger students, they filled in all of these holiday cards that we gave as part of our gift to Isaac House. And then because it was so popular and people were enjoying these cards so much, we decided to go forward and we made these little holiday tags. So we took the same pictures, but then we put them on like little gift tags that you put on a present. And then we manufactured them, we marketed them, we were very proud of them, and then we raised over 150,000 won for Isaac House. Going back to more of the mathematical component, what are the key concepts as we're looking at this material? So for this grade 10 unit, it actually covered several different units, and then we looked at modeling through the lens of form. What does the form look like that we want to create? We looked through the lens of logic, and then we looked through the lens of relationships. And the unit that we just finished, we focused on the relationships. So the way I'll describe to you how that's important is that in grade 9, the same group of students who are now in grade 10, in grade 9 during VLE, they had to collect some data. So they did things like running up and down the stairs and timing their heartbeat or timing how long it took, etc., and they collected all this data. This student did how many seconds it took him to hold a plank versus his heart rate. They plotted their data on a coordinate system, and they created a best fit line going through it. But then we encourage the students to reflect, like, do we think this is actually a linear relationship? Do you think that your heart rate will continue to increase at a constant rate? And of course, most students said no, not for something like this. My heart rate is probably going to level off a little bit like we're seeing here in this. And now in grade 10, after we've studied all of these different functions, now students are actually empowered to choose the function that fits the best. So students again looked at data. This year, same student looking at pole vaulting data. So this was the height that people jumped in the Olympics over the pole vaulting. And you can see that the data kind of increases and then kind of levels out. And then it again looks like it increases a little bit, and then it looks like it leveled out. And so the students started to notice, maybe I could break this function, and I could put a domain restriction, so I have one function here and then one function here. But then they had to do some research. Why would this be two different functions? Why would pole vaulting suddenly change? And so this student did the research, and he found out that they changed the materials that they made the poles right around that time. So that's what he was seeing. He was seeing the potential increasing and then kind of leveling off, and then with the new poles and the new material, again, increasing and then leveling off. So that allowed him to come up with a very nice clean model where he could show that exactly. Yeah. All right, so just pulling all that back together again, because that was a lot of material. Here in our unit, our math skill was functions and transformations, looking at different functions and how do they move around the coordinate system. How do we investigate? What patterns do I see in transformations? This is where they explored everything on Desmos and came up with the rules themselves. What kind of inquiry questions can I ask? What other functions could fit my curve? How can I get it to fit exactly the way I want it to? Low floor, high ceiling, working with circles, working with ellipses, rotating functions, inequalities. Key concepts, relationships. Relationships inform my modeling decisions. I expect the graph to level out because I know human potential will end up leveling out. So let me choose a function that will level out. Connections. Can I connect this somehow to science? Can I connect this somehow to material development and design? Can I connect this historically to Olympics and human potential? Approaches to learning. A lot of critical thinking going on in this unit, interpreting that data and identifying the trends, and then trying to decide when it's appropriate to make some predictions. Global context. What's the big takeaway? For us, it was technical innovation. What makes modeling important in today's world? How do they apply in the real world? We had a little discussion about modeling outbreaks, which is what Miss Sophie will talk about as she gets into the DP program. We also had the librarian do a short little segment on vector drawings, which is basically exactly what we were doing in Desmos. This is how you would create all of the vector drawings that you see online. And of course, the nicest part, in my opinion, was the service in action, our gift cards, our gift take fundraising, and just the idea of bringing the community together around what we were doing in math. So I hope you've enjoyed what I have shared with you about the MYP, and I will let Ms. Sophie take it and explain a little bit about our DP.
Hello, I am Miss Sophie and I will be introducing math in the DP. So the DP curriculum is constantly adapting. Here I'm going to present you a video of Joe Bowler who's describing how it adapts to the real life.
We're at an exciting time, both in terms of the knowledge that's available in the world and the ways the knowledge is being made available. We're also at a time when it seems clear that we need to rethink teaching and learning, incorporating the tools and technologies that are available. Teaching and learning in a 21st century way seems important for schools and for teachers and parents, but it's also important for all of our lives. To show you just how important this time we're living in is, look at this statistic. This tells us about the time we're in now. Some people are calling this the data revolution. Our lives and our students' lives are filled with data, and all students should leave school being able to make sense of data and learn ways to separate fact from fiction. As we all move around in the world, decisions are being made about our lives using data. So being a data literate citizen is now an important part of living in the world. And over 50 college majors ask for a statistics or data science course. All subject teachers can take a data perspective, as our new online course shares. Data science can also really help modernize mathematics, as it encourages an approach of studying patterns, not in a superficial algorithmic way, but as an explorer who uses 21st century tools like computers and coding to investigate data sets and communicate findings using cool data visualizations.
So as you can see, we can do a lot of data analysis nowadays. However, at ISB and in the DP
We're
curriculum,
at an exciting time, both in terms of...
We also focus a lot on technology, communication, and collaboration. It's really important that our students can use technology to present well their findings and to help other people to understand them. We have two math choices. We have application and interpretation, and analysis and approaches. As you can see, the two graphs on the left present in the application curriculum the different hours spent on the different topic. We can see that there are many more hours spent on functions and statistics and probability. Rather than in the analysis curriculum, you can see that the hours are a little bit more balanced in the analysis SL, but there's many more hours spent on calculus and trigonometry in the HL level. In the DP curriculum, as I mentioned, it changes every day and we adapt every year. At ISB, we want the curriculum to be based also on students' interest and their area of interest. We want them to bring to life, including their interest, we want them to bring to life the different topics and what they would like to discuss and learn from in the different 5 topics we have. Our unit plannings are adding depth to the student learning. If I'm using the example that we've been discussing in the MYP modeling, in the DP, what we can extend it to, let's say we take linear, exponential, logarithmic functions, we can again start with inquiry, but we can push the questions into all the different types of model that there are. We can also ask the students, how do we choose the best model for a data set? And then with that, it enables us to model and to look into prediction and to look for the future. This is a very good tool in many fields, and technologies are very good ways to represent and to find those best models. The key concept is the relationship, because we connect the variables together to make prediction and to find how they are related to each other. It helps us to do some research, and then the students can make connections with different subjects, biology, modeling, economics, and they can then discuss some more research topics, such as the different models for Ebola, the common flu, coronavirus nowadays. And then those students, they can apply much better in the real world, and they can model those diseases. They can understand how variables affect the models, and they can look at the reliability of the models when they make prediction. We can also extend those different models too more difficult topic when students are looking into low floor, high ceilings. So we can involve calculus when looking at the SIR model. We can also look at the growth of different curves, again, using calculus, and we can use multiple variables if necessary. Sometimes it allows us to make links with TOK, and we can then discuss how the model gives us knowledge, even if it doesn't yield accurate predictions. Here I will present you some topics that the grade 12 students chose for their explorations that they have to submit at towards the end of the grade 12. So we have one of the students who modeled the SIR model in the US for one of the disease. You can see that they've been using technology to present the curves, but through the technology they've been looking and analyzing the different growth and decay that they can observe. The students use this representation to understand better differential equations. In the other topic, we have one of the students who've been looking into paracetamol concentration in the blood over time. We see here the understanding and analysis of the student through the different points, trying to model best the curve and trying to fit those points with some understanding of the different curves they've been looking into. We see the whole line of thought that allowed the students to model the first 2 points, and that led us to the last curve. Again, thank you so much for joining us today. We wonder, how does your experience of learning math compare to what you've learned today? Did you learn anything new that could help you work with your child at home? If you have other questions, please let us know and get in touch with us by email at any time. And we hope that we can support you further. Please advise us if there's any way.
We'll leave you with a few resources that you can look at your own time. Parent resources, first of all, of course, your parent's teacher. If you have any questions, please feel comfortable asking them. The second one is UCubed. This is run and organized originally by Jo Bowler, the video that we watched earlier. She has lots of fantastic resources about learning math. Enrich also is a lot of investigation type resources. Excellent website. We have Khan Academy, which the students use regularly, and we also have Khan Academy and Map, which is a website that you can go to and put in the students' math scores, and then they'll get videos that are catered exactly to their level at this point. And then just references that we used during the video in case you want to see them again. The first was Jo Bowler Science Initiative video, and the second one is some information about the DP courses. So thank you very much for coming. Have a good day.